The teleop period is 2 minutes long, including the endgame. This is 80% of the match. A good interface between the robot and the human driver is important for a successful match. We use the OnBot Java to program a robot. It's a simple system that allows us to utilize our fail-fast, fail-frequent, and fail-forward design concept. We started our robot programming by creating an object for each subsystem. For a servo-based subsystem, like the claw and the pivot, we created 3 functions: open, close, and toggle. We use a variable to keep track of its state. This year's robot uses several servos, so we were able to reuse the code. Our lift is powered by a single motor. We use run to position mode to set and hold its position. We calculated the number of encoder tick counts for each level. Using the tick count, we were able to create 3 functions: elevator up, elevator down, and go to level. With these functions, we are able to use our lift like an elevator and stop at the correct height for each level. We then programmed the joystick buttons to execute these commands. Next, we ran several 2-minute-long teleop cycles. We recorded the sequence of buttons pushed to pick up the stone and stack them. The sequence is: turn on the intake, drive forward into the stone, close the claw, elevator up so we don't hit the side of a robot, pivot to the drop position, elevator up and down to align it to the correct level, align the stone over the tower, lower the stone over the tower, open the claw, home the pivot, and home the elevator. Using this information, we created a finite state machine. The state machine allows us to move forward and backward through the sequence. Here is the updated joystick button assignment. The main button is now the next statement button. The driver uses this button repeatedly to go through the sequence. The only other button used is the elevator up or down. This finite state machine allows us to have a single driver and operator. This eliminates errors from miscommunications between a 2-person driver and operator. The single driver is able to react faster and doesn't have to talk to the operator. After our first tournament, we added red blinking LED lights to indicate what state the robot was in. We have competed against many robots with similar capabilities. We believe our single drivers is what gives us the competitive advantage.